Assalamualaikum and hello to our panel and our fellow friend. My name is Muhammad Ali Zafri bin Abdul Rahman. Today I will be present about review on coastal and shaft break front characteristic and dynamic. Oceanic front usually are found in narrow zone of horizontal gradient which identified by discontinuity in temperature, nutrient or salinity content. Front was identified by temperature, density, and salinity driven where two different water mass meet. Temporarily, front was formed by photogenesis mechanism and resistant to the turbulence. There are three steps for methodology. The first one is planning the review, which is I identify the need for the review. And the second step is conducting the review, which is I select the study and quality assessment and analyze the iteration of data. The last step is reporting and dissemination, which the writing report and recommendation start. There are two objectives for this study. The first one is to determine the characteristic of fronts in the coastal and shaft sea, and the second one is to identify the dynamic process in coastal and shaft front formation. Next is result and discussion for my objective one, which to determine the characteristic of front in the coastal and shaft sea. The collection of data from the table 1 show the type of front from location, characteristic of front, and the reference. The tidal missing fronts were usually formed in shallow coastal, which tidal missing front is impermanent and warm. Upwelling front can be located in both coastal and shaft sea, which they are higher in nutrition and have cold temperature, while shaft break can only be found in continental shafts that are permanent and have unique geostrophic jet along the front. We are moving to result and discussion for objective 2, which is to identify the dynamic process in coastal and shaft front formation. Table 2 shows the collection of data from NOAA-NASA Pathfinder sea surface temperature field in large marine ecosystem. These are the tables which show the tidal emissive front dominate in large marine ecosystem. Tidal emissive front is one of the coastal front where it located at shallow subsea, which tidal steering is too weak to keep the water column mixed. In result, the boundary in between stratified and mixed, which is front. There are two other processes that form the tidal emissive. The first one is surface buoyancy flux that produced from solar radiation, and the other one is the kinetic energy dissipation that come from the tidal current, which make the tidal emissive front itself impermanent that depend on tidal current and solar radiation. Others dynamic change is wind give a big impact to forming of tidal emissive front due to the wind-induced shear dispersion in resulting of low convergence occur. The next table will show the outwelling fronts dominated in large marine ecosystem. Usually, outwelling front forming in open deep sea, but outwelling front exists in coastal and shaft. In coastal, it happened at offshore, while in shaft, it happened at onshore, and the way it upwelling or downwelling happened due to the massive difference in nutrient between in different water mass, which front will separate these two water mass, and the temperature of the front is quite low, which in result cold in temperature, and on the offshore usually higher nutrient compared to the onshore. And current in the sea is an important role in upwelling and downwelling transportation indirectly influence the outwelling front. The last table in boundary current and self slope dominated in large marine ecosystem. The shaft break front form in the transition zone between any different property made, and some of the front are permanent due to the feature of the topography of the shaft, like continental slope at mid-Atlantic bight. And the front of the shaft break is completely barrier, mean that front is formed on the surface until the bottom of the ocean due to the geostrophic jet along the front. In result, decline any new formation of shaft due to the jet that causes cross shaft flow be zero across the shaft break front. Lastly, the turbulence in shaft also influence the fronts due to the turbulence makes the specification in front if it's strong enough to break through the front. In conclusion, coastal and shaft front will escalate the temperature, salinity, density, and nutrient gradient while driven by various mechanisms. And then, the type of front will always be influenced by the dynamic process. And the front is important for a large marine ecosystem due to the rich in nutrient and become the hotspot for marine productivity become more important feature in oceanography for further study. And this is my reference, and thank you.